In this lesson, you will learn to solve quadratic equations by using completing the square. Now, just a little review on different types of equations. There are three main types that you should be familiar with. And the first type is what we call a linear equation. And the beginning of this course, we were dealing a lot with linear equations. How to graph a line, how to find the slope, etc. A linear equation is something where the x and the y terms are both raised only to the first power. So we see we have 3x to the first power and 4y to the first power. Whereas a quadratic equation is when one of the terms is raised to the second power, such as 3x squared plus 4x plus 5 equals 0. And a third type to know is what we call a cubic equation, where we have a term that is cubed or raised to the third power, such as this third example. Now in this lesson we are dealing with quadratic equations. How do we solve equations where you have a squared component? Now to do this, using completing the square method, which we'll discuss a little later, we first need to be aware of how to work with radicals in equations. And so this should be a little review for you, but I do need to go through this to make sure you understand, because this is going to be key for completing the square process. So here we see y squared equals 49. If you are told to solve this, because we want to get rid of the squared in the y squared term, we need to do the opposite of squaring, which would be taking the square root. So what I can do is I can take the square root of both sides. So I have the square root of y squared equals a positive or negative square root of 49. Well, the square root of y squared will cancel each other, so I'm left with just a y, and then a square root of 49 would be a 7. So y would equal either a positive or a negative 7. Here's another example where now we have something in parentheses squared, and the same idea. To get rid of the squared, I can do the opposite of squaring, which is taking the square root of both sides. When I take the square root of a squared, that will cancel, and I'm left with just a y minus 6. And then the square root of 49 on the right side, don't forget it would be a positive or a negative, so I get y minus 6 equals a positive or a negative 7. And by the way, in case you've not learned what this notation means, a plus and a minus on top of each other simply means y minus 6 equals a positive 7, or it could equal a negative 7. So then to solve for y, I can add 6 to both sides. So now I have y equals then 6 plus or minus 7, which, as we said, means plus 7 or 6 minus 7. 6 plus 7 is 13, 6 minus 7 is negative 1, so y would be 13 or negative 1. Now one more example where now instead of just a y, we have a 5y minus 6. And still the same thing. We want to get rid of the squared, so we take the square root of both sides, which will get that to cancel. And I'm left with 5y minus 6 on the left side, and then a positive or negative 7 on the right side. And by the way, if you don't like dealing with a positive or negative sign like this, you could break it apart into two equations right at this point. But if you are okay with it, we're just going to go through and leave the plus or minus in until the end. So what I want to do is get y by itself, and I can add 6 to both sides. So now I have a 6 plus or minus 7 on the right side. And then to solve for y, I divide both sides by 5. So now I have 6 plus or minus 7 over 5. Which, don't forget, means I could break it apart as 6 plus 7 over 5 or 6 minus 7 over 5. Which this would then give me a 13 over 5 or a negative 1 over 5 as my solutions. Now for each of these three examples, notice the key concept, that if I have the squared term on one side completely by itself, to solve I can just take the square root of both sides. Notice each of these, the squared term is by itself. We have y minus 6 squared, 5y minus 6 squared. Here we have y squared. if we have something squared on one side, I can then take the square root of both sides and then solve. So using that concept, we are going to learn how to do what's called completing the square. And what it is it's a way to solve quadratic equations. And we've learned before that we can factor to solve a quadratic equation, but there are times when factoring will not get you the solution. Some polynomials are not factorable. So here's an example where I cannot factor x squared plus 6x minus 4 equals 0. So what I need is another method for solving this quadratic equation. How do I solve this for x? So this is level 1 difficulty. This is one of the easier examples. And then after this one, we'll increase to level 2 and level 3 difficulty. And the concept for each of these, though, is we want, by the end of this, for the left side to become x plus or minus something, and then in parentheses, squared, equaling a number. Okay, that is my objective. Because once I get to this point, I know that I can take the square root of both sides to solve. So that is my goal. I want to force x squared plus 6x minus 4 into this format, where I have a perfect square on the left side and a number on the right side. And that is why it's called completing the square, because I'm creating or forcing a perfect square to occur so that I can take the square root of both sides and then solve. So what I need is I need the constant term on the right side. So this negative 4, I need to move over by adding 4 to both sides. So now I have x squared plus 6x equals 4. And then my objective, like we said, is to create a perfect square on the left side. So this is where the process comes in. This is where the kind of confusing or kind of weird process takes place, where I need to put a blank right here on both sides. And what I'm going to do is I'm going to add something on both sides so that this left side becomes a perfect square. So to make this into a perfect square, what I do is I take this middle number, this 6. I take half of that number and then square it. So I take half of 6 to get 3. I square 3 to get 9. And that's what I'm adding to both sides. So once again, I'm taking half of the 6 and then squaring it. Half of 6 is 3. You square 3 to get 9. And that's what I'm adding to both sides. And then from here, we're assuming you know how to factor at this point. When you factor, this will become x plus 3 squared. Right? To get 9, I need a 3 times a 3 to get 9, and when I add them together, I get 6. So this becomes x plus 3 times x plus 3, which is x plus 3 squared. So now we have a perfect square on the left side, the constant on the right side, and I know from here that I can just take the square root of both sides to get the square to cancel. And I'm left with x plus 3 equals a positive or negative square root of 13. Solve for x, I can subtract 3 from both sides, and I get x equals negative 3 plus or minus the square root of 13. And notice there's no way that you could have gotten this answer by factoring. So this method is one way, when it doesn't factor, in which I can solve. So that is level 1 difficulty. Here is level 2 difficulty. And the difficulty comes in this example because I'm going to have fractions. And many people, or I'd say most people, do not like fractions. And we see here the 2 in the front of the y squared term. This is what's going to make it a little more difficult with fractions. So my end result is still going to be the same, where I want to have y plus or minus something squared equaling some number. Okay, so let's start by putting the number, or the constant term, on the right side. And then we'll worry about the 2 in the front. So we can add 5 to both sides. where now we have 2y squared plus 2y equals 5. And now we can deal with this 2 in the front of the y squared term. We need to get rid of that 2 in order to do completing the square. So what I like to do is get rid of it by dividing by 2, because 2 times y squared, when I divide by 2, will cancel, but I need to divide everything by 2 as well. So now I have y squared. This becomes a 1y, and then the 5 over 2 is just 5 over 2. And then you want to leave yourself a blank on both sides, because I'm going to add something to make the left side into a perfect square. Well, what we're going to add is found by taking this middle term, this coefficient, which in this case is a 1. I take half of the 1, so 1/2, and then I square it. So half of 1, and then I square it to get 1/4. So I'm going to add 1/4 to both sides. And then when I factor the left side, remember this is a perfect square, so I know that something squared is going to give me the 1/4, which is going to be the 1/2. This becomes y plus 1/2 squared, because 1/2 times 1/2 gives me 1/4. 1/2 plus 1/2 gives me a 1 back out. So this is how you'd factor. And notice all I put here, this 1/2, came from this number here that I was squaring. And it's going to be a plus because of this plus sign right there. Okay, and then on the right side, I need to add 5/2 plus 1/4 by getting a common denominator. So I've done that as well in this step, where I converted 5/2 into 10/4. So from here, I can combine 10/4 and 1/4 to get 11/4. And then I need to get rid of the squared by taking the square root of both sides. When I take the square root, this will cancel or undo each other. I'm left with y plus 1/2 equals, and then on the right side we have a positive or negative square root of 11 over 4, which can break up to be the square root of 11 over the square root of 4, and the square root of 4 is going to be 2 for the denominator. And then solve for y, one last step, just subtract 1/2 from both sides, so we have y equals negative 1/2 plus or minus the square root of 11 over 2. And that is my solution, but it's best practice to combine into one fraction if possible. So notice we have a common denominator of 2, right? So I can combine this into one fraction by adding the numerators. So I have for the numerator negative 1, and then plus or minus square root of 11 over 2. And we can leave it like this as one fraction. Or if we wanted, we could break it into two different solutions because we have a plus or a minus square root of 11. But either way is fine. But it's better to combine into one fraction. So that is level 2 difficulty because of the fractions. Level 3 difficulty is only level 3 because it has more not so friendly fractions. So here is level 3, where same concept, I need to get rid of this 2 in the front. And I first need to get the constant term to the right side. So I can add 5 to both sides. And I'm going to get 2y squared plus 3y equals 5. We need to get rid of the 2 in the front of the y squared term by dividing everything by 2. So now we have y squared plus 3 over 2y equals 5 over 2. And this is level 3 difficulty because filling in this blank is going to be a little trickier, only because we have fractions and people don't really like fractions. But the process is still the same, where to fill in that blank, I need to take half of this and then square it. Well, half of 3 over 2, you take 3 over 2 times 1/2 to get 3/4. So half of 3/2 is 3/4, and then I square 3/4 to get 9 over 16. 3 squared is 9, 4 squared is 16. So that is part of why this is more difficult. But then also the factoring is a little more difficult as well, because now we have fractions that we are factoring. But just like in the level 2 difficulty, when I factor, I know it's going to be y and then plus something, because this is a plus sign right here. And then what's going to go here in this blank is going to be whatever's being squared to get to 9/16. Well, how do we get 9/16? Well, we got that by squaring the 3/4. So this would become y plus 3/4 and then squared. Okay, so that's y plus 3/4 squared. And then on the right side, we have to add these together by getting a common denominator. So I got a common denominator of 16, so I convert 5/2 into 40/16. And on the right side, 40/16 plus 9/16 can combine to get 49/16. And from here, I can take the square root to get rid of that squared. So that's going to cancel each other out. I'm left with y plus 3/4 on the left side. And then on the right side, we have the square root of 49/16. Square root of 49 is 7. The square root of 16 is 4. So the right side is 7/4. Then solve for y by subtracting 3/4. So now we have y equals, and then negative 3/4 plus or minus 7/4. Well, that's two different solutions. I can combine those fractions to get my two solutions of negative 3/4 plus 7/4 or negative 3/4 minus 7/4. So for the first equation, we would get 4/4, which would be 1. Second equation would give me negative 10/4, which would be reduced to be negative 5/2. So in this lesson, you've learned how to complete the square with multiple levels of difficulty. And you see that there are certain times when completing the square can be kind of messy process. And actually, this third example right here, the one we just did, this one actually would factor. So if you can factor, usually it's best or simplest to factor if possible. But if not, we've now learned that we could do this method of completing the square. And in the next lesson, we will learn yet another method. And that method is called the quadratic formula. And that concludes our lesson for today. We will see you next time.